Hello and welcome to this video. In this video we'll be solving yet more difficult trigonometric equations and finding multiple answers to those trigonometric equations. Alright, I mustn't say very difficult because they're not that hard. Alright, let's look at this very first example. We've been asked to solve this equation for values of theta between 0 and 360 degrees. Now, this simply looks like a quadratic equation to me. Let's replace sine theta with some other simpler variable like x. That's the same as solving that equation there, x squared minus 3x plus 2. Notice all these squares on sine theta means just a square on x. Alright, so factorize that and set those factors equal to 0, you end up with x equals to 2 and x equals to 1. Therefore, if you solve an auxiliary equation and show that you've solved this equation in an exam, and then you may even be able to skip this line in the middle and go straight to this last answer, this line here in sine, right, sine theta is 2 or sine theta is 1. Then you check your answer. Can sine theta take a value of 2 at all? No, I don't think so, because the sine curve never reaches that far out. Therefore, we can discard one of the solutions already and look at the next solution. I know for a fact that sine theta only has one solution, which reaches 1, and that is 90 degrees there. But take sine inverse of 1 just to show and be sure. And we check within 360 degree. If I use um, my knowledge of what I know, 180 minus 90 will give me yet the same 90 back. So um, I, I'm not discarding this identity here, remember? So this gives me the same 90 back because curve is actually symmetric around 90, so you don't get any other values with using this identity that we learned previously. So do use the identity, but adding 360 of course to this 90 will take us beyond the range. So 90 is the only answer there. Now, once more, you see an equation like so, treat it like a quadratic and factorize it, you end up with two solutions. Okay, they both seem to be valid at the moment, so let's take one of them at a time and solve it. So, taking sine inverse of a half, negative half, will give us 120 degrees. If your calculator doesn't give you 120 degrees, let me check my calculator. It's negative because it does give you that principal value, but then you say with 360 minus that angle I would get 240. Now that's one way of thinking about it. I would have simply done 360 minus 120 and that would have given me the other alternate other value that we need as well. So both of these are between 0 and 360, so they are both valid. So then we are using this equation that we've finished with that, and we are using this value. Cos of theta equals to 1, take cos inverse of both sides, you get 0, and adding 360, they are is 360. So notice those values are valid because the inequality does have equality inside as well. So there you go. So we get two solutions from one, cos theta is 1, and two solutions with cos theta equals to negative half. These are the four solutions that are within our range. Okay, so that's the end of that problem here. There. So this third example has sine theta squared, the angle there in the bracket, you got theta minus theta. So you do need to adjust this range a little bit by taking away 30 from both sides of the inequality. You end up with 330 here on the right and negative 30 on the left, but I don't think it will make much difference. But in any case, you should do that. Now, taking the next step of solving this equation is tricky. So what you're going to do is you're going to take what? You're going to take a square root of both sides, and that means putting a plus minus sign in front of the answer. Alright, so then let me just get rid of my writing. Square root means you have to put the plus minus. So that is two different answers that you have there. Treat them under two different roots that you have to take. First, you taking the positive square root. Now, sine inverse of 1 over root 2 is going to give you 45 degrees, and you're going to make sure you remember this identity. Sine of theta is the same as sine of 180 minus theta. So we're going to take that, say theta, our theta is 45. Now put that 45 here, and 180 minus 45 is 35. Okay, now we're gonna go and look at the negative square root and make sure you understand. Alright, so there you go. There's two answers, 45 and 135 are there on the graph for you. Now we're gonna look at the negative root. Alright, so putting that on the calculator, taking sine inverse of both sides, give you minus 45 degrees. You're going to do the same trick here. You're going to do 180 minus a minus 45. It will give you 315. Well, no, that is just adding 360 to 45. And we haven't done, you're not finished here yet. You are going to do 180 minus 45 to get 225. Alright, so these are the other two valid solutions there. Okay, so we added 360 to the negative angle just to make it positive, because we need to have between 0 and 360 degrees answers. So write them nice and neat on one line, and don't forget to add 30. We still need to add 30 there, and we end up with these answers. Beautiful. We do have one more question to look at. Alright, so this time our answer needs to be between negative 180 and positive 180 degrees. Now, with this kind of a quadratic, we need to tidy things up and make sure all the equations either in terms of sine or in terms of cosine. So what would you do? You might be thinking dividing, but no, because dividing by sine or cos square will leave us with a nasty fraction here. Sine over cos square is not a good idea. So let's first of all, you can you can see, because we have 9 sine x here and 3 sine square here, we need to manipulate this cos square and turn it into sine. How? We're going to use this famous trigonometric identity. We say that the cos square is 1 minus sine square. So 1 minus sine square x there plus 9 sine x, and we might as well bring and subtract this 3 sine x from both sides, sine square x from both sides, and we'll end up with 2 minus 2 sine square x plus 9 sine square x. You do have to write maths to show that you understand and you don't make errors. So now we have actually minus 5 sine square x. Minus, let's make that 5 clear, uh, minus sine minus 5 sine square x plus 9 sine x, and we're gonna put that 2 at the end here. Now it might be easier to multiply everything by a negative 1, so that you get a positive coefficient there. So I might as well put bracket around there, and this 2 becomes a minus 2 here. And alright, so let's see, can we factorize this? If I take 5 and multiply it by 2, I'm just going to write s square minus 9s minus 10. s equal to 0. So I took that 2 and multiplied it there. So I'm just going to write the note for myself. I need to divide by 2 at the end. Once I try to factorize this, I'm going to have what? Sine s minus 10 plus 1. Okay, so I'm going to put minus 10 here and s plus 1 here equals to 0. So s equals to 10 and s is minus 1. Now, now, sorry, I forgot. This divides by 2 and this divides by 2. I forgot the division by 2. So it's actually s equals to 5 and s equals to a negative half. Okay, so that's why I put this. So when I factorize this, I end up with two answers. Sine of x equals to 5, which is impossible, and sine of x equals to negative half. Alright, so this is possible. And I have there what I need to work with. In this one I'm gonna have to discard because sine curve never reaches as far as 5. And now, taking inverse sine of negative a half, so sine inverse of minus half will give us negative 30 degrees. Alright, so we're not finished yet. This negative is one of the valid answers there, but don't forget sine of negative 30 is equivalent to sine of 180 minus a minus 30 makes this a plus, and the other angle is 210. And 210 is beyond 180. So what else can we do? We can say there is here I'm going to write for myself that I multiplied by 5, so I remove this 5 in front of sine, so I need to divide by 5 and the last step. So inside the bracket I'll put minus 10 and plus 1 here, and because those are the answers to factorization, and I need to make sure I divide by 5 here. So one of the answers will give me sine is equals to 2. The other answer is telling me that sine of theta or rather x, sine of x is equals to a negative 1/5 because I divide by 5 now here, so I'm done there. So the answers I'm going to write here, sine x equals to 2 is not going to be valid, but the sine of x being equal to minus 1/5 is a valid answer. Therefore, we're going to take sine inverse of both sides there, and we will have, if we put that on our calculator, x will be 11, negative 11.5, right? So this is a valid answer there, but we also need to find other answers there. Now, if I sketch you the sine curve, uh, we figured out we are figuring out the answers there, and also in the negative on the negative sides. This is the y-axis. Sorry about my drawing. Maybe y-axis is here, not there. So then, what we are saying is that we need to find other answers. What we just figured out is that it crosses the line here. Okay, so what did we do then? The thing beyond this is 180. We don't care about this side of the graph, and this is negative 180. So our other answer lies somewhere in the negative values. All right. So this is a tricky part that you always have to picture the graph for yourself. However much you went away from zero, is the same amount that you're going to come back from negative 180. So you're going to take 180 and basically you think of it as the same rule minus a minus, or you can say I'm going to add this angle that I have as a negative. I have negative 11.5, so I'm going to add it. Or you could think of it as this minus a minus. All right. This is the point where the graph, all right, is like symmetric around here at minus 90. So that's why it's happening here. All right. So when you put that on your calculator, you are basically going to get 168, and that's negative 168. Okay, so negative 168.4 is the other valid answer. Okay, so you say x equals to finally minus 11.5 degrees comma negative 168.4 degrees. Alright, maybe there should be a 5 as well. Okay, so we're going to round it to one decimal place. All right, so another way to think about the same problem to find the alternate angle is to use this cast diagram. All right, all along we've been looking at this diagram where you find four angles, four quadrants. It's called cast because here's where cos is positive, I must say. Here's where all angles are positive. Here's where sine is positive, and here's where tan is positive. Now, here all angles tan, sine, and cos are positive. In the top two are sine is positive, and so on. So here we're looking for angles between negative 180 and 180. We said that if we try 180 minus this isn't going to work. 180 plus 100 and plus 11.5 is going to go above this range. That's no use. So what is the other angle? Well, the other angle, you could think of this as we are looking at a triangle which is down here. Okay, its angle is negative 11. So this negative 11.5 is saying that we've turned clockwise here. The triangle is here. Its equivalent cos. Well, sorry, this is sine. So its equivalent sine is where the down over here, the opposite side of that y value is also has the same. This other triangle, this right angle triangle here, has the same side. So what's the angle for that? If you think about it, this is 0. Not only is the other side 180, you think of that as negative 180. We've turned all the way clockwise here, that's 180, and we are now looking at minus 11. So negative 180 there, minus 11.5 will give us the other angle we're looking for. That will tell us if the other angle is 106, negative 168. All right, 0.5. Okay, I hope you found this last bit useful. Good luck practicing. See you later.